Hello class and welcome to today's lesson. We're going to be proving Pythagorean's theorem. So what we're going to do is we're first going to look at these four triangles. Now this sign right here means that they are congruent, meaning they share all the same side lengths and angle measures. The most important feature of these triangles is that they are right angle triangles. Now I'm going to give you some side lengths. We're going to say that this shorter side here is 3 inches, that this longer side is 4 inches, and then we're going to say that we do not know our hypotenuse. Now again, because they are congruent, that means that this side is 3 inches, and this side, same for this, and we do not know our hypotenuse. So we're going to go ahead and look at this square. Now this is the longer side, so we know that that is 4 inches, and this is the shorter side, so we know that this is 3 inches. We're going to try to find the area of this whole square and see what we get, and then we're going to take the area of the triangles and subtract that because we want to find the area of this blank space. So we're going to add this together to find the full side length of our large square, which is going to be 7 inches. And then we're going to go ahead and just to make sure that it is a square, which it should be with the way I lined it up, this short side again is 3 inches, and then we have our longer side, which we know to be 4 inches. Add that together, and we get 7 inches. Now, another important component of being a square is that it is all right angles. So the right angle is opposite of the hypotenuse. So we see our hypotenuse here, so we know that there is a right angle. We know our hypotenuse is here, so we know that is where our right angle is, and again, this will happen for all of our triangles because they all share the same measurements. So we have officially proven that this is a square because it has equal side lengths and it has right angles. So now what we're going to do is we're going to find the area, and we're going to call this big square just so that we know the difference between the area of the large one and the smaller one. So we're going to go ahead and do 7 times 7 inches, which will give us 49 inches squared. And don't forget about your units, they're very important. Now, what we're going to do is we're going to find the area of one triangle because they're all the same. Once we have the area of one, we can multiply it by 4 to get the full area of all of them. Because again, we want to find this area. So in order to do that, we're going to take the large area of the square minus the triangle, and that's going to leave us with this blank space here. So let's do the area of one triangle, which we see, let's do our green one here. We know that it has a height of 4 inches, so we're going to do our half from the equation, our 4 from the height, and then our 3 from the base, which is going to give us 6 inches squared. Now we're going to find the area of 4 triangles, which is going to be 4 times 6 inches. Again, like we discussed before, because they're all the same, we can do this. And that's going to give us 24 inches squared. Now we have our area of the large square minus our area of all those triangles, and that's going to leave us with this blank space here, which is going to be 25 inches squared. So we have officially found this whole area, but now I'm wondering what the side lengths are. So I'm going to go ahead and square root this because we can see it's a square here. So let's go ahead and let's label this c squared, which is going to be this area whole, 25 inches squared. And we're going to go ahead and square root that. Because of that, the square root is going to cancel out the squared, and then we just have to go ahead and square root 25, and 25 is a perfect square, so we actually get 5 inches as our side length. Now, let's go ahead and look at this square. wouldn't you agree that if the triangles keep their measurement and the large square keeps its measurement, it doesn't matter how we distribute the blank space, these two blank spaces will add up to this one large blank space. Now that makes logical sense, but let's go ahead and prove it. So we're going to go ahead, and again we can notice that this is the long side of the triangle, which we know to be 4 inches, and this also is the long side of the triangle, which we know to be 4 inches. So we are going to go ahead and do 4 times 4. So let's do area, let's go ahead and label this 2 and 1, just to keep track that they're separate. So of square 2, which is going to be equal to 4 times 4, which is equal to 16 inches squared. Now we see here that this is the shorter side, and this also is the shorter side. So once again we have a square, and we're going to do area of square 1. And that's going to be 3 times 3 equals 9 inches squared. So in order to see if it matches up with the area and the side lengths, we're going to go ahead and just add them together. So we have 16 inches squared plus 9 inches squared is equal to 25 inches squared. And isn't that exactly what the area of the large square was over in here? So now we're just going to go ahead and plug in some variables that you might be a little more familiar with. So let's go ahead and erase that, and let's put in an A here, a B here, and a C here. So if this over here, the long side we labeled B, and this is A, and if this side is B on this triangle, we know this to be A, and that would be C. And this will kind of repeat itself. Oh. And this will be C, B, A, and C. That was very, there we go. And B and C. So we would agree that the area of the blank space here would be C squared. And then these are the short sides. So we'll go ahead, and the short side here is labeled A and A, so we would agree that this would be A squared. And these are the longer sides of 4 inches, which we have now labeled B. So we would agree that that area would be equal to B squared. So what that means is we have proven that A squared plus B squared equals C squared when you have right